Welcome back. In the last video, we looked at the parallel lines and transversals theorems, which all started with if a transversal intersects parallel lines, then we know my corresponding angles are congruent, my alternate exterior angles are congruent, my alternate interior angles are congruent, and my same side interior or consecutive interior angles are supplementary. And then we looked at the converse. What happens when I switch? Instead of then proving the values of the angles, then this time we're going to start with we know what the angles are. We know our corresponding angles are congruent, so our lines are parallel. I know my exterior angles are congruent, so my lines are parallel. I know my alternate interior angles are congruent, so my lines are parallel. Or I know my same side interior or consecutive interior angles are supplementary, so my lines are parallel. Now, how do I know when to use the theorem and when to use the converse? Okay, well, let's look at some examples that we're going to do. It says use the figure below to answer each question, then determine which theorem or converse was used to answer. Okay, and then it gives us a little note. It says each question is new and should not be impacted by the previous answers. And that's oftentimes how it works. When you have one figure and then you have a bunch of questions that follow it, you take each question as if you're starting from scratch with that image. Okay, you start fresh each time. Okay, so when I look at number 1, it tells me given that the measure of angle 1 is 52 and the measure of angle 7 is 52, it wants to know, is line M parallel to line P? So I'm trying to prove that lines are parallel. So which one concludes that lines are parallel? Not the theorems. Those don't conclude my lines are parallel, right? But look at my converses. My converses all conclude that I've got parallel lines. Okay? So now I just have to figure out, I know I'm using the converse, okay? Anytime we're trying to, so I'm going to write this down so we don't forget. How do we know? Are we using, using the theorem or the converse? Okay, if I'm using the converse, that's what this first one we just talked about is. I'm trying to prove that I have parallel lines. Okay, so that's how I'm going to be able to tell I'm using the converse. Okay, if I want to use the theorem, I'm going to be given the information that the lines are parallel. I'm going to start with that. And it's going to ask me to find the measure of an angle. Or it's going to ask me to find x, or it's going to ask me to find some value, okay, or x, or a value, or something, okay. It's going to start with, yes, I know I have parallel. Use that information, okay. So when I look at number 1, and it says, given that angle 1 and angle 7 are 52. They're both 52, so they're congruent. So 75% of the time, we do want them to be congruent, but we need to look at the relationship in those angles and make sure that it's not that other 25%, okay? So let's see. All of these are going to have, remember when I used my pencil and I said, oh, I've got a transversal in maroon, and then I've got my other 2 lines, okay? Either these 2 or these 2 or these 2 that I'm looking at. Okay, my transversal, that's the only transversal I can have in this figure because it's the only line that crosses the others. So I'm just going to worry about the 2 lines. So I'm looking at angle 1 and I'm looking at angle 7. So if I look at the 2 lines that intersect at 1 and 7, that's my M and that's my P. Okay, so now I'm trying to decide what type of angles are those. This one, oops, slid everything around. This one is above the transversal because this is my transversal. This one is below the transversal. 1 is above, 7 is below. And they're both outside the 2 yellow pencils. So those we call alternate exterior angles. I'm going to abbreviate alternate exterior. And since I'm trying to prove that M is parallel to P, I'm trying to prove that I have parallel lines. It's the alternate exterior converse that I'm going to be using. Okay? And the alternate exterior converse says if my alternate exterior angles are congruent, then yes, my lines are parallel. So angle 1 and angle 7 are both 52. So I can say yes by the alternate exterior converse. Okay? So we want to have both of these answers because it does say up in the directions, determine which theorem or converse was used to answer. So we used this converse to give the answer of yes. Okay? When I look at number 2, this time it says given that M is parallel to N. So I know starting out that M is parallel to N. So since I already know I have parallel, I'm not trying to prove I have parallel. I'm starting with given my lines are parallel. So I'm starting with, I've already got parallel lines. So I'm starting with these, which means I'm starting with a theorem. I'm not trying to prove parallel. I already know it's parallel. So I'm using a theorem. I'm going to abbreviate it, THM. Okay, let's see if we can figure out which one. We know that M and N are parallel. So I'm looking at M and N, these two lines here. My M is this one, and my N is this one. And let's see what two angles we're working with. I know they're parallel, so I know my corresponding angles are going to be congruent. My alternate exterior, alternate interior are congruent. It's just the same side interior that are not congruent. Okay? All right. Angle 2 is 122. So that's this angle right here. And angle 3 is what I'm trying to find. So look at where those two angles are. Okay? So those two angles are on the same side of my transversal Q. They're both above it. Okay? And they are both inside those two yellow pencils. So they're on the same side and they're inside. Those are same side, interior. And I'm using the same side interior angle theorem that says if two lines are parallel, which should tell me they are, then these two angles are supplementary. So the measure of angle 2 plus the measure of angle 3 is going to equal 180. I know angle 2 is 122. Okay, so now to finish solving, all I have to do is subtract the 122 on both sides. So the measure of angle 3 equals 180 minus 122, which I believe is 58, just want to make sure. 180 minus 122 is indeed 58 degrees. And I can prove that using the same side interior angles theorem. Okay. Let's look at number 4. I don't know what happened to, oh, my 4 and my 3 got mixed up. That's okay. We'll do number 4 and then we'll come back to number 3. All right, number 4, given that the measure of angle 11 is 52 and the measure of angle 3 is 56, is line M parallel to line N. So I'm trying to show whether or not I'm trying to prove are the lines parallel, which means I know I'm using a converse. Okay, but which converse is it? So let's see. I'm looking at lines M and N. So M is there, N is there. So I've already got M and N with my pencils. And I am looking at 11 and 3. So here's 11. And here's 3. Okay, so those two angles, one's above the transversal Q, one's below transversal Q, so they're on alternate sides. So now are they alternate interior or alternate exterior? Well, they're inside the two pencils, so they're alternate interior. Alternate interior angles converse. Okay, So my alternate interior angles converse is going to allow me to answer this question. 11 is 52 and 3 is 56. Well, alternate interior angles have to be congruent if I have parallel lines. Okay? If these aren't congruent, then that means no, I do not have parallel lines. Okay, I do not have parallel lines because my alternate interior angles are not congruent, so I don't have parallel lines. Okay, it's kind of like the inverse of the converse. Okay, all right, now we'll do number 3. Given that N is parallel to P, so now I'm looking at line N, that's this one, and line P, that's this one. And this time I'm starting with that they're parallel. And I'm going to be trying to find, it says, what is the value of X? So this time I'm using the theorem. Okay? So this time I'm using the theorem. But which theorem is it out of the 4? So let's see. When I look back up, we're looking at the angle 3. Angle 3, that's already there, and angle 5. So this one tends to confuse a lot of people, these two angles. When I was noticing when I graded your assignment from Monday, this one was commonly missed, how you call these angles. Notice they're both above, so they're on the same side of the transversal, but they're not both interior. One's interior, one's exterior. These are both above the transversal and to the left of the line thereby. They are in corresponding positions, okay? So these are corresponding angles. So this is the corresponding, I think I spelled that wrong, 2 R's. Corresponding angles theorem is what we're going to be using. And that says if 2 lines are parallel, then the corresponding angles are congruent. So my corresponding angles are 3 and 5, so they should be congruent to each other, which means they have equal measures. So the measure of angle 3 is equal to the measure of angle 5. So then I'm just going to substitute. The measure of angle 3 is 7x minus 2, and the measure of angle 5 is 47. Okay, so that's pretty simple to solve. I'm going to get the 7x by itself by adding 2 to both sides. 7x plus 0 equals 47 plus 2. I'm going to divide both sides by 7, my division property of equality. And then x equals 49 divided by 7 is 7. Okay? All right, what I would recommend doing next is I would recommend pausing the video to see these 4 questions and see 5, 6, 7, and 8 and see if you can answer those questions. And then in the next video, we'll see if you get the same answers that I get. Okay, thank you so much for watching.